Okay, so in this example, it says the time that it takes for the next train to come follows a uniform distribution. There's our keyword. With f of x equals 1/45th, where x goes between 7 and 52 minutes. Round answers to four decimal places. Okay. First off, this is a uniform distribution. It says it right there, uniform. And it's continuous. What does continuous mean? Does it mean smooth? Means there's no jumps. In other words, it doesn't jump from say, it could take 7 minutes or 9 or 41. No. It could take anywhere between 7 and 52. Uniform means continuous, smooth, meaning even Steven. It could take 7.1 minutes or anywhere from 7 to 52 minutes for the next train to arrive. Okay, down here, the mean. How do we find the mean? Well, the mean's the middle. It's the average. So what's the average time it's going to take? Well, this is A and B. It's going to be A plus B divided by 2. So 7 plus 52 divided by 2, because that's going to be the middle of the interval. Here's it is on the notes. Chapter 5 notes, 5, 6, and 7. Mean is A plus B divided by 2. that's the middle. That's the average of two things, right? The middle. If you add them up, you'll get 59 over 2. Hit the buttons on your calculator, 29.5. All right. 40, yeah, 50, yeah, there it is, 29.5. Yep, that's the answer. Yeah, so that's the average time. Why? Because it could take anywhere from 7 to 52 minutes for the next train to arrive. So the average time is 29.5 minutes. It's just the middle of those two numbers. You add them and divide by 2. All right, next comes the standard deviation. I'm just going to use the formula. Standard deviation is right here from the notes. It's the width, b minus a over square root of 12. So let's go there. So b minus a, whoops, minus a over the square root of 12. So that's 52 minus 7 over the square root of 12. So that 45 square root of 12. Go to the calculator. So I'm going to go, here's the one. Here. Here it is. So if you hit the calculator on the home page, you get this. You can go to any of these other than number one. Like I'll go to number two, for example. And then it'll pop up with a calculator. We're not going to use the one on the main page. We're just going to roll down to the bottom, and there's the scientific calculator. Hit that one. I already forgot what the problem was. What was it? It was 45 over the square root of 12. So then we go, okay. Gonna use this one, hit the fraction button. 45 over the square root 12. There we go. 12.99038. 12.99038. 12.99038. You can just type that in, that's fine. They rounded to the 4. It'll take it either way. It's all good. Okay, next one. Find the probability the time will be at most 17 minutes. Okay, at most 17 minutes means the most it could be is 17. 17 or less. So what does that mean? What's the lowest it could be? 7. The lowest it could be is 7. So we're really saying from 17 down to 7, right? Because we know don't forget this, they told us the next train will arrive for sure between 7 and 52 minutes. Okay, so 17 or less means 17 all the way down to the quickest it could arrive is 7 minutes. So you know probability. It's always the number we want over the total. So the number we want is we want it to come somewhere between 7 and 17 minutes, right? At most 17. No, the least it's going to be 7. So we're hoping it'll be somewhere between 7 and 17. We know that the total range is B minus A is, what is the B now? 7 to 52, right? So 52 minus 7, it's for sure going to come somewhere in there. That's a 10-minute range out of 45 minutes total. Let's go to the calculator and divide. 10 out of 45. 10 out of 45. There it is. Point twos all the way. Point twos, sure enough. Yeah, so yeah, because whenever you do probability, it's always the number we want over the total. The total range of times, it's going to come anywhere from 7 minutes to 52 minutes, right? Uniformly. So we subtract that's a 45-minute time interval. It's going to come anywhere in that 45-minute time interval. We want it to come at most 17, meaning somewhere between 7 and 17, because 7 is the quickest it's going to come. That's a 10-minute interval out of the 45. That's 22% of the interval. There's a 22% chance it's going to come in that interval. Next one, find the probability time will be between 10 and 23. Okay. 10 and 23. Well, again, we're just going to subtract those because that's what we want. We want it over the total. We want it to come between 10 and 23. The total, it's going to come anywhere between 7 and 52. So that'll be 13 over 45. Divide that in your calculator. You're going to get the 0.28. And you can just type in a bunch of eights. That's good enough. They rounded, well, eventually to a 9, whatever. Is that right? 13 out of 45. Let me double check that one. 13 out of 45. Do we do that right? Yep, there it is, just like they said. Okay, so that's good. Okay, now the next one, the G here, get a little more room for G. G is the 90th percentile. So how do we do that 90th percentile? Well, the formula is right here. Percentile is right there for the formula. So A plus, so I'll go, okay, P90, it's A plus P over 100 times B minus A. So it's 9, no, not 90. Let's try again. What's A and B? They're up here, right? A and B. Here's A. You can read it. It's getting a little scribbly. Here's A, here's B. Start and end. So 7, 7, 52. P is 90. 90 for 52 minus 7. And just go to Desmos. 7 plus 90 over 100. 7 plus 90 over 100 times parentheses 52 minus 7, I think. 47.5. So we got 47.5. Beautiful. That's the 90th percentile, meaning 90% of the people will wait 47.5 minutes or less, right? Everybody's going to wait from 7 to 52 minutes. 90% of the people are going to wait 47.5 minutes or less. Okay, last question, and maybe the most tricky. Let's see. H. So part H. Other probability time is more than 20 minutes given or knowing that it's at least 20. So this is a given or conditional question. And the formula for that, come up here, is right here, is right here. And it says the width of the section described over the total section width possible given the condition. Okay. Width described over total width given the condition that they specified. Okay, so what does that mean? That means, see what they said? Um, so what find the probability it is more than 22. Okay, so that's what they describe, more than 22. What would that be? Well, more than 22, what's the most it could be? We know the train's coming between 7 and 52 minutes. The most it could be is 52. 52 minus 22, right? If they want it more than 22 minutes, what they're saying is that there's maybe the train will come between 22 and 52 minutes because we know the most is 52. It's definitely come between 7 and 52. So more than 22. That'd be that gap, whatever that comes out to be. I think that would be, oops, 30. That's a gap of 30 minutes. That's a 30-minute gap. They want it to be more than 22. Means a 30-minute gap. Over. Now, what's the total width of the given kid? What's given? Given knowing that it's going to be at least 20. So for some reason, whatever the reason, somebody's already radioed ahead. They know the train is delayed, whatever. They're telling you, hey, it's going to be at least 20, which means what? 20 or more, meaning the least it's going to be is 20, could be more, 20 or more. So you're given that condition. You know it's going to be 20 or more. So you know it's going to be between 52 and 20, right? Which comes out to be 32 down there. We're going to divide those in our calculator. Do you see that? That's how given works. You do the section described. They said more than 22. That's just kind of normal. Over what they gave us condition. We know, we're told, we radioed ahead. And they said, hey, it was delayed at the last stop. It's going to be at least 20 minutes. It might be more. So it's going to be between 20 and 52. What's the chance it actually ends up being between 22 and 52? Subtract those, divide in your calculator. 30 over 32. Boom. 0.9375. Sure enough, that's our answer right there. Okay, now let me help because sometimes they say this differently. Sometimes they will, someone should help you recognize, they'll say What's the probability now? More than 22, x is greater than 22, and then they'll put a line. So that means more than, right? More than 22. They'll put this line, and that line, let me get rid of this. That line, that straight line that they put there, it won't make it quite that big, but I'm just being clear. It means given, knowing that, it's at least 20. That means x is greater than 20, at least. So sometimes you'll see it in words, like ours is in words here for the train one, and sometimes you'll see it written like this. When you see that big straight line or small straight line, whatever, it means given. You think, oh, it's one of those given ones. I got to write the given formula. And the first part's what they're asking. That's the top. This is always the top. This is what they're asking. Greater than 22, 52 to 22. And this is the denominator over here. Greater than 20, at least 20, meaning between 20 and 52. That's what's given. So either way, they can give it with symbols, with a straight line means given, or they can give it with words. Either way, we can handle it. Here we go.